Good afternoon, one and all. Today we will study another method of descriptive testing method, that is hardness testing. In a previous lecture, I already told that destructive testing methods. There are two methods in a metallurgy. One is a destructive and second one is a non-destructive testing. First one is a destructive testing, and that various methods: tensile, compressive, shear, bending, like that, and non-destructive dye penetration, ultrasonic, radiographic, like that. In previous lecture, we studied destructive testing, the tensile test. Here, we will study hardness testing. Hardness testing is also one of the very important parts for a design, manufacturing, and research purpose. Destructive testing means in which we are just breaking the component. Introduction. Definition of hardness is a material's resistance to indentation or penetration. Hardness is nothing but it is a material resistance, that material resists to indentation or penetration. For that purpose, that hardness test is carried out. Importance. Hardness testing is used to evaluate a material's wear resistance, strength, and toughness. Hardness is very important testing to calculate is wear resistance, material strength, and toughness. Normally, we are doing heat treatment, various heat treatment process like annealing, normalizing, like that, case hardening, throw hardening. Such type of hardening is taken, or heat treatment we are doing. The main soul of that heat treatment is a wear resistance. So, it is important hardness testing to evaluate materials wear resistance, strength, to evaluate its strength and toughness. There are mainly three types of hardness test. First one is a Brinell, second one is a Rockwell, and third one is a Vickers. Brinell test is depends on the diameter of indentation. Rockwell test is depends on the depth of indentation, and third one is Vickers test, which depends on the rhombus is created and the diagonal of rhombus. We will study here Brinell hardness test. Already told that Brinell hardness test is important to, or it depends on the diameter of indentation, and we are normally doing test already studied for wear strength to calculate its resistance to wear strength and toughness. The principle of Brinell hardness is, or Brinell hardness test principle is, a hardened steel ball indents the material. A hardened ball it indent on the material, and the diameter of that diameter of indenter is important to calculate that Brinell hardness material. Apply a known load to the ball. For particular material or particular ball diameter, load is fixed, and that for according to the ball diameter, load is applied to the ball. Then measure the diameter of the indentation. When impression is on a ball or impression on the material, then the diameter of indenter is very important to calculate the Brinell hardness number. And calculate the Brinell hardness number, through that Brinell hardness number is calculated. Advantages. This Brinell hardness test is important and it having some advantages, like it is suitable for soft to medium hard materials. It is very suitable, Brinell hardness number is very suitable for soft to medium hard material. That is hardness is near about 20, near about 200 to 50 bhn. That is, it is normally used for soft to medium hard materials. Disadvantage, may not accurately measure the hardness of very hard material. Some cases we are doing throw hardening, in some cases we are doing case hardening. For such purpose, The disadvantage of this system is may not accurately measure the hardness of very hard material. It will not measure hardness of very hard materials. Rockwell hardness test. Another next test is a Rockwell hardness. I already told that it depends on depth of penetration. The principle of Rockwell hardness test is a diamond cone or steel ball indents the material. Steel ball, as usual, used in a Brinell hardness. We can indent on the material, or normally the procedure is a diamond cone. Is normally used in indent to material. This technique is mostly used. The procedure for Rockwell hardness test is apply a minor load to the indentator. We have to apply load to the indentator, and the indentator may be steel ball or diamond cone. But in this lecture we consider diamond cone used as indentator. We are applying a minor load to the indentator. Load calculations are fixed according to that load calculations. The diamond cone to that diamond cone load is applied. Apply a major load. Okay, actually we are applying a major load on the component, and I already told that measure the depth of penetration. We have to measure the depth of penetration and calculate the Rockwell hardness number, that is called as a HR. HR is nothing but Rockwell hardness number. There are three types of Rockwell scale: HRC, HRB and HRF, are also called as HRE. HRC is used for hardened steel like throw hardening or case hardening materials. HRB is used for that soft materials like non-ferrous materials. HRF or HRA is used to very soft material. For normally in industry, HRC is calculated to hardened steel, that is through case hardened steel or through hardening steel, because in case more than 50 HRC hardness is there, 50 to 55, near about 60 HRC hardness is there. This is the small diagram of how that hardness is measured. In a specimen is there, minor load is applied on this indentator, then gradually increasing major load is applied. So small indentation will be there on that work specimen, and through that, by calculating diameter, we are calculating Brinell hardness number. By calculating depth, we are calculating that Rockwell hardness number. And third and very important is a Wicker hardness test. Normally there are two types of Wicker hardness test. It is Wickers as well as micro Wickers. When we are doing case hardening to 1 or 1.5 mm or maximum 2 mm depth, it is very difficult to calculate the hardness of that material, because itself the die penetrate wall indentation is too much high in diameter, so we cannot get very much points. In that case, Vickers hardness is used. The principle of Vickers hardness test is a diamond pyramid indenter the materials. Again, diamond pyramid indenter is used as a material for Vickers hardness test. Procedure: apply a known load to the pyramid, that is to the diamond indenter or diamond pyramid indenter. We are applying a fixed load or known load onto that. Measure the diagonal length of the indentation. Already told that rhombus is created by that load applying on that indenter. We are calculating diagonal length, major diagonal length and minor diagonal length of the indentator, and calculating Vickers hardness number, that is HV. Again repeating, there are three types of test: Brinell, Rockwell and Vickers. Brinell hardness will depends on the diameter of indentator. Vickers hardness will depend on the depth of indentator, and Vickers hardness will depend on the diagonal length of the indentator. And according to that, we are calculating the Vickers hardness number by using the diagonal length of indentator. Advantage of this test is accurate for a wide range of materials, including very hard ones. It is very accurate method for wide range of materials, including very hard load. Considering that case hardening material, there may be hardness of more than 50 to 55 HRC and the case depth is very small. So it is very useful because hardness test to measure very hard materials. The disadvantage is this is requires a microscope for accurate measurement because that indentations are very small. We can't see by naked eyes, so it requires microscope for accurate measurement. It is the one of the type of Vickers hardness test. In red color, sample is there, and through we are applying Vickers indenter, the diamond Vicker indenter there. We are applying load, particular load to that. So there is a small impression on the workpiece in form of rhombus. So we are measuring major and minor. Already told that major and minor diagonal of that major and minor diagonal of length of the indenter, and through that Vickers hardness is calculated. The various factors affecting hardness testing. First one is the load. Higher loads generally results in higher hardness value. If you are applying high load, then higher hardness values are there. Indenter, the types of indenter, it may be ball, cone or pyramid, affect the hardness measurement. Surface finish, rough surface can influence hardness readings. And last one is the test method. The specific hardness test method chosen can impact results. These are the various factors affecting on hardness testing machine. Application of hardness testing. Hardness testing is used in a material selection. Choosing appropriate material for specific application useful for design engineer. Quality control, ensuring product consistency against same as we studied in a tensile testing. Then it is again used in a research and development, that is studying material behavior and improving properties. For improving property, we are using in a research and development. Failure analysis, that is investigating the cause of material failures. Material will fail, so for material failure, investigating the cause of material failures. Again, it is very important to calculate modulus of elasticity, and that modulus of elasticity is nothing but a measure of a material stiffness, and second one is the calculation slope of elastic proportion to stress strain curve. We already studied in a tensile testing. Conclusion: the summary of hardness testing is: hardness testing is a vital tool for evaluating material properties. That hardness testing is important to calculate various material properties, and linearly it depends on diameter of indentation because it depends on depth of indentation, and Rockwell depends on depth of indentation, and because it depends on the diagonal length of the indentation. Importance: it provides valuable information for various industries and applications. Use various hardness value of material to design engineer, research engineer, and any other fields. Thank you.